Okay, let's add some information that is related to human impacts, but somewhat maybe indirectly related to climate change. So this is a nice website called Visual Capitalist. It provides graphics of many interesting things that you should look up. So visualizing the scale of anthropogenic mass. In 2020, the amount of anthropogenic mass exceeded the weight of all global living biomass. If you take all things that are alive and look at what we created more mass than all global living biomass. So imagine big whales, elephants, humans, 7 billion, whatever, and we created more junk than that. As humans continue to dominate Earth, questions surrounding our material output are increasing. We break down the composition of all human-made material and the rate of their production. So we look at anthropogenic mass or human-made mass, referring to the materials embedded within inanimate solid objects that are made by humans. Okay, so here we are, 1120 gigatons global biomass. The dry weight of all life on Earth is comprised of plants, animals, bacteria, fungi, protists, archaea, and viruses too. We created 1154 gigatons. That's the anthropogenic mass. Here is everything human population has created since 1900 to 2020. All humans make up about 0.01% of global living biomass, so we are not that big. There is this allometric scaling idea that you can look up. I have podcasts on it where the biomass of a species, average biomass of a species, body mass of a species versus biomass, which is the sum of all the members of that species, has a certain relation that you should look up. So the smaller the things, more they are in number, so their biomass is higher because of the amount of food that needs to be available as the body mass increases. So humans, we created 1 gigaton is 1,000 million metric tons. We created 549 gigatons of concrete. Concrete is the most frequently used building material and the second most used substance in the world after water. How about that? 92 gigatons in bricks. Approximately 1,500 billion bricks are produced each year. More than 85% of this annual production comes from Asia. So China and India grow as they should, and construction boom continues, and concrete and bricks are used obviously to build everything. 386 gigatons in aggregates of clay, sand and gravel. Aggregates are particulate materials used in construction. Some examples include sand, gravel, crushed stone and slag. Aggregates are the most mined materials in the world. Sand mafias in India run amok, and they are somewhat out of control in many places because sand is a very valuable commodity when you want to build buildings, and building buildings and selling them is one of the most profitable business anywhere in the world, but especially in China and India. 39 gigatons of metals. Since the Bronze Age, metals have become increasingly prominent in human culture. Iron is the most commonly used metal found in alloys like steel. 65 gigatons in asphalt, also known as bitumen. Asphalt is a semi-solid form of petroleum commonly mixed with aggregates to form roads. So asphalt is laid on the roads, and as you know now, US is going into this infrastructure binge where climate is supposed to be part of the action, but if you read some of the Interior Department reports, it's not clear. Climate change is percolating into all the money that will be spent in the coming years from this $1 trillion infrastructure fund and so on. 23 gigatons of other, including that includes wood, glass and plastic. All plastic, around 8 gigatons, has now more than doubled the total weight of the entire animal kingdom. Okay, so all plastic, 8 gigatons, has now more than doubled the total weight of the entire animal kingdom. Okay, so you can think about that. So these trends highlight the alarming speed and volume in which human contributions are impacting the world. And finally here, the current rate of accumulation for human-made mass is approximately 30 gigatons of mass per year. 30 gigatons of mass per year. This is equal to each person on Earth producing their own weight in human-made mass every week. Just think about it. Every week we are producing our own average weight of mass that is artificially created for us. Nothing natural about this, most of the things we produce. As accumulation rates increase, the amount of human-made mass is predicted to almost triple the amount of global living biomass by 2040. Okay, so here you can see 1990 to 2020 to 2040 projections. So we went from around 1000 gigatons, 1254 or whatever we looked at, and we are going to go up to here, and these oops, let me see, yeah, so let me leave it there. That's the kind of the oops, let me add a little bit more. Human-made mass includes concrete, aggregates, bricks, asphalt, metals, and other, as we saw. So used for buildings and infrastructure. Concrete is used for buildings and infrastructure, including cement, gravel, and sand. And each one creates massive environmental problems. Sand mining on riverbeds is incredible devastation happens in large parts of India. Aggregates include gravel and sand, mainly used as bedding for roads and buildings. Bricks mostly composed of clay and used for constructions. Asphalt is bitumen, gravel, and sand, as we said, used mainly for road construction and pavement. Metals include iron and steel, aluminum, and copper. So production of iron, steel, and aluminum are massively energy intensive, so they are going to be big problems. Already they are big contributors to emissions. Copper mining is in general a huge problem, especially even for renewables. Cobalt and other precious materials being mined are going to create massive problems for increasing renewables at the rate that we want to increase for phasing out fossil fuels. So that battle is already started for cobalt, for example. Other include solid wood products, paper, paperboard, container, and flat glass and plastic. So look at the mass of each. Concrete from 1900 to 1940 to 2020 in mass per gigatons of mass went from 2 to 10 to 86 to 549 gigatons. Aggregates went from 17 to 386. Bricks have gone from 11 to 92. Asphalt was basically non-existent in 1900. Now it's at 65 gigatons. Metals went from 1 to 39, and others went from 4 to 23. So this should add up to 1254 or whatever the number we looked at. That is larger than all the living species together. So animal kingdom are at 4 gigatons. Plastic is at 8 gigatons. So twice the mass of plastic compared to the animal kingdom. Are we special or not? Just to end on a good note, this website also provides you solar power by country in 2021. You can say this is largely good news if we don't worry about the details of life cycle analysis and what will happen to the solar cells that have run their lifetime and so on and so forth. So in Europe, Germany dominates here, with Italy doing pretty well. In Asia and Oceania, China dominates. India is doing pretty well, trying to grow as rapidly as it can. Japan is the second largest. South Korea is here. Taiwan, Vietnam, even Vietnam is doing pretty well. Okay, so it is just to say that even though 25 years of negotiations haven't budged the total emissions yet, The efforts to innovate on carbon capture, utilization and sequestration, renewable energies, electric vehicles, and all sorts of other technologies for reducing our impacts on food, agriculture, food, energy, water, and health continue. So one has to just watch carefully to see how quickly we catch up to the required goals in terms of reducing emissions to meet our 2 degree C warming or 1.5. 1.5 is pretty much going to be impossible unless a miracle game changer comes along and starts to suck out carbon dioxide from the air very rapidly and hide it somewhere. Barring a miracle, we are pretty much going to head to 2 degrees C warming by 2100. The question is how far above that we are going to go and what it will mean locally and regionally, for especially for the so-called global south, the developing countries in Asia, Africa, South America, and of course also the Western Hemisphere like Haiti and Dominican Republic, Cuba, and so on. Okay. Good news is that population continues to drop. China and India report flattening of the population. Fertility rates have been dropping, so that may make a big difference as well. We'll see. But as I said before, decreased population unfortunately is not coming with decreased total consumption, because people have fewer kids and each kid now consumes more than poor people who have a higher number of kids. So it's a complicated issue still.